the first they are asked to find whether the system is time invariant or variant. So the first question is x y of t is equal to x of t square. Okay. So what is time variant is if I um, vary the time output time by t, the input also vary by t. The input also it has to be varied by t. Okay. So if this is a case, it is called as time invariant. Okay. So if it is not, means it is time variant. Okay. So here you can see since that instead of t I'm getting t square. So if I vary t by my so if I shift the t by capital T, so it will result in x of t minus t the whole square, right? So you will get x of t square minus 2t of t minus plus t square, right? This is the answer you will get. Whereas if I change it, t the input by t, so you will get x of t square minus t. So you can see both are different, right? So here the y of t minus t is not similar to that of x of t minus t. So it is time variant. So this is for continuous signal. The same it is for discrete signal. So if y of n is equal to x of 2n, so you can see the it is multiplied by something. So definitely it is time variant. So instead of t, you have to use capital N. So if it is the case x of 2n minus n, so this will result in x of 2n minus 2n. So whereas if I replace n minus n, it becomes x of 2n minus n. Okay. So here you can see the y of n minus n is not equal to x of n minus n. So it is time variant. But whereas if we see if suppose y of n is equal to x square of n minus 1. So in this case, if it is plus or minus with n, it is definitely it is time invariant. So you can see. So you don't worry about this x square and all. Why? Because if I shift it by n, so this becomes n minus n minus so. Whereas if I shift n minus n, you will get x square minus n minus 1. So it is time invariant. Okay. So next, so if we consider fourth problem, okay, x of y of n, so y of n is equal to x of minus t. So x of minus, yeah. So this is definitely a time variant, right? Since it is being scaled. Okay. Next, if suppose y of n is equal to x of n plus n into x of n minus 1. So if n is changed shifted by minus n, so we'll get n minus n into x of n minus 1. So whereas if I change only the x of n by minus n, it becomes x of n minus n plus n into x of n minus 1. So here you can see it is time variant, right? Because y of n minus n is not equal to x of n minus n. Okay. So let us go to the sixth problem. So suppose you see y of t is equal to x of t into cos of 40 pi t. So if I replace t minus by minus t, I will get x of t minus t cos of 40 pi t minus t. Whereas if I replace only x by t, I will get x of t minus t cos of 40 pi t. So here y of t is not equal to x of t minus t. So it is time variant, right? So let us go to another problem. Suppose the question is d of y of t by dt plus phi t y of t is equal to x of t. So, since in the y of t, I have a t term. This is nothing but time variant. Okay. Suppose if I don't have the t term, suppose if I have only 5, okay, then it comes under the time invariant. Okay. Why it is time variant? Because of function of t. At y of t, right? Suppose if I have a question like this, okay, d square y of t by dt square plus 2 y of t that is equal to x of t. So here it is nothing but time invariant, since it is not a function of t. Since you can see this one and this one is not function of t. T square like that. Okay. So now let us go to another problem. Y of n is equal to summation k is equal to minus infinity to infinity in n plus 1 x of k. Okay. So here you can see this, if I expand this one, the x of k is from x of minus infinity up to, it will go up to x of n plus 1. So before that it is x of n. So here you can see the n is not coming, it is not scaled, and it is also and it is there is no function n into x of n like that or not. So this is definitely a time invariant, right? The similar is a case for so suppose the question is given like this. Okay, so the convolution similar, right? This is also look like a convolution only, right? X of tau d tau. So if I integrate this one, I will get x of tau divided by 2, right? X square, maybe it will be x square or something. Okay. It is ranging from minus infinity to t. So and you can see it may be like x square of t, right, by 2 minus plus of x square of infinity, like that it it may come. And you can see it is not being scaled, right, and there is no function like t is coming at the beginning of x of t and done. So this is also, it is time invariant. Okay, so next 11th problem. Suppose x of n is equal to sine x of n. So I can tell this is definitely a time invariant, right? Because y of n minus n is sine of x of n minus n. So if I change x of n alone, it is also x of n minus n. So that is time invariant. So if you have any other doubt regarding this problem, you can ask me. So let's go for log of x of n. Log of x of n also, that is time invariant. And suppose the question is like log of x of n. Okay, log of x of n. That is also, it is time invariant, right? Of it is signum n. Signum signum x of n function. That is also, yeah, time invariant too. Okay. So suppose they are given the question like this. Okay, y of n is equal to x of n into u of n. So here you can see the n get multiplied with x of n. So definitely this is a time variant term, right? Since you see x of n minus n is equal to x of n minus n, u of n minus n, where if I change only x of n minus n, it becomes x of n minus n into u of n. So here y of n minus n is not equal to x of n minus n. So it is time variant. So I think that's all about the video. Thank you very much.